Alright, it's not really going to be much different from what we've already been doing in 8.3 and 8.4 using your sine, cosine, and tangent. You're going to be more accountable for drawing the pictures, though, throughout this section. Okay? And in order to draw the pictures, within the descriptions, they talk about the angles of elevation and the angles of depression. So that's really what this lesson is focusing on, is can you put these angles in the correct place and can you identify them correctly in a picture? At the top, you've got the typed out definition for each of these. The angle of elevation is defined as an angle formed by a horizontal line and the line of sight to an object above the horizontal line. An angle of elevation will be above the horizontal line. Angle of depression is the angle formed by a horizontal line and the line of sight to an object below the horizontal line. Your angle of depression will always be located below the horizontal line. It's sad, right? It's below the line. Elevation, I think up, so you're above. Below those two definitions, you have a diagram that looks something kind of like this, right? Okay. Here's Bill. And Bill is looking up at an airplane. Okay. This is the line of sight. In those definitions, it talks about the line of sight. It's the line that connects the two objects. Then your line of sight will always have two horizontal lines coming from it. You've got a horizontal line at the top, and then you have a horizontal line at the bottom. This angle here, that's touching the top horizontal line, is it above this line or below this horizontal line? Below. So if you have an angle formed by a horizontal line in the line of sight, and it's below the horizontal, then this is an angle of depression. And that's because it's below the horizontal line. The other angle here is formed by the line of sight in the bottom horizontal line. Is this angle above the bottom horizontal line or below it? Above. So if you have an angle above a horizontal line, then it's called an angle of elevation. And that's because it's above the horizontal line. Those horizontal lines, will they ever meet, cross, touch? No. So if lines don't ever meet, cross, or touch, they're what kind of lines? Parallel lines. So if we go back to chapter 3 and think about parallel lines, how can I classify the angle of depression and the angle of elevation? Alternate interior. And way back then we said if the lines are parallel, then alternate interior angles are what? Congruent. Alright, so your angle of depression and your angle of elevation will always be congruent. Between the same two objects. And that's because they're alternate interior angles. So the angle of depression, the angle of elevation between the same two things, between Bill and the plane here, they will have to be congruent to each other because they are alternate interior angles. If I was looking up at the flag, the angle of elevation from my eyes to the flag would be the same as the angle of depression from the flag down to my eyes. Okay, between the same two objects, those angles will be congruent. The first part of your assignment is being able to correctly name and identify the angles and explain how they're being used. So that's what we're going to do here on this example with this picture. Instead of filling in all these blanks below the picture, you can actually just cross that stuff off. We're going to describe them over here to the right side of the picture. So cross off all that mumble jumble below the diagram. And we're just going to describe angle 1 and 2 over to the right side. So first, to decide if angle 1 is an angle of elevation or an angle of depression. Depression. Why would you say depression? Because it's below a horizontal line. Good. Angle 1 is below the horizontal line it is being formed by, so it's an angle of depression. From what to what? Where does angle 1 start? The plane, and it goes to the lighthouse. So angle 1 is an angle of depression from the plane to the lighthouse. Angle 2. First you have to decide if it's an elevation or a depression angle. Why would you say elevation? Because it's above the horizontal line that it's touching. Good. From where does angle 2 start? The lighthouse, and then it goes up to what? The plane. So this is from the lighthouse to the plane. You have to make sure the order of your objects match what you're saying. Elevation, you're looking up, so you have to start at the bottom object and go up to the top one. Okay, so wherever that angle starts, that's where your first object should be. That's not so bad, is it? You have about 5 of those on your assignment today. Okay. Some of them, the picture will already be given to you, like number 2 here. So on number 2, it says a surveyor stands 200 feet from a building. Yours is already labeled, I'm pretty sure. To measure the building's height with a 5-foot tall theodolite. A theodolite is an angle measuring device. Okay, so like think of this 5 feet as being a tripod, and then the theodolite is on the top of it, like you put a camera on the tripod. And then wherever you aim the theodolite up at, it's going to measure that angle of elevation to whatever your object is. So we're going to the top of the building. In this one, it says the angle of elevation to the top of the building is 35 degrees. So above our horizontal, we have this 35-degree angle. We're trying to find x, the height of the building. Yours is all nicely labeled like that, right? Okay. Again, this shouldn't be any different from what we did the last 2 days using sine, cosine, and tangent. In reference to 35, is x opposite, adjacent, or hypotenuse? Opposite. How about 200? Adjacent. So SOHCAHTOA tells us to use which trig function? Tangent. Good. Tangent of 35 equals x over 200. Make sure you show me that line of work. I'd rather see that one than the one that comes after this. Anna, how would you punch this into the calculator? Yeah, 200 times the tangent of 35. Haley, did you already punch it in? What did you get when you took 200 times the tangent of 35? About 140 feet? You guys agree with that? Okay. Good. My theodolite is sitting on a what? Tripod. What's my tripod on? The ground, right? So this is ground level here. My x goes from the top of the building to the bottom of the triangle. Is this where my building will stop? Shouldn't, right? It's not floating. My building's got to go down to the ground too. So this portion is 140 feet. What was this distance? 5 feet. So really, how tall is my building then? 145. We have to add that 5 feet on there, and then our building is about 145 feet. Okay, so you have to read carefully. If the picture's already given to us, double check your picture. If you have to draw it yourself, read carefully and double check your picture. If the angle of elevation does not start on the ground, then you're gonna have to add whatever that distance is. Sometimes they say like Susie's looking up at an angle of elevation of 30 degrees and her eyes are 4 feet off the ground. Well, my angle starts 4 feet off the ground, so then I'm gonna have to add that 4 feet to figure out whatever the height is of the thing I'm looking for. Okay, so just make sure you read carefully. Good on that one? Cool, flip it over. We're gonna skip 3, we're gonna go to 4. And on 4, they want us to describe angle 3 and angle 4 as it relates to the situation. So you have to decide if it's an angle of elevation or an angle of depression, and then from what to what. Nicole, for angle 3, would you say it's an angle of elevation or depression? Depression. Why would you say it's an angle of depression? Good. From which 2 objects, Nicole? Good. From the lighthouse to the person. Jackson, how about angle 4?
Elevation.
From what to what?
From the man to the lighthouse.
Why did you say elevation?
Because it is above the horizontal line.
Good, because it's above the horizontal line. Dan, you have like 5 or 6 of those today. Number 5. You sight a rock climber on a cliff at a 32-degree angle of elevation. So you are down here in the bottom left corner. Angle of elevation is going to be above the horizontal line. I know yours is already labeled, so there's your 35 degrees. The horizontal ground distance to the cliff is 1,000 feet.
32.
Oh, it says 32, sorry. So then here's my 1,000 feet. Find the line of sight distance to the rock climber. So you are actually trying to find the hypotenuse this time. Line of sight is the line that connects the 2 objects. And again, this is really similar to what you were doing the last couple days. Lobs in reference to 32, 1,000. Opposite, adjacent, or hypotenuse?
Adjacent.
How about x?
Hypotenuse.
So which trig function would we use? Good. Cosine of 32 equals 1,000 over x. Make sure you show me that work. Let's see, how would we put this into the calculator?
You would do x, or wait.
You weren't here for this? Okay, let's get x by itself. So if it's in the denominator, good. So we're going to multiply both sides by x. And then, like, see, I have x times the cosine of 32 equals 1,000. Now, these are being multiplied, so how do I move cosine over? Not if they're being multiplied. What's that? Divide, right? So we're going to divide both sides by cosine of 32. So then what we're left with is x equals 1,000 divided by the cosine of 32. So when x is in the bottom, you divide. If it's in the top, then you would multiply. Ruth, if you put 1,000 divided by cosine 32 in, what'd you come up with? 1179. 1179? You guys agree with her? Okay, so some of them today you'll already have the picture, or they might start the picture and you have to add in a little bit of information. But then your other ones, you got to do it all from scratch, which is what we're going to practice on the next page. Remember, this chapter is really focusing on right triangles, so your pictures have to have right triangles. So if you want to just draw a right triangle and label it based off that, you can. I like to put a little bit more detail in my picture because then it makes more sense to me when I'm reading the word problems. So on number 6, an airplane pilot sees a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. We want to know the airplane's surface distance from the raft. Well, if I have an airplane pilot, I better have an airplane. And then we've got a raft. I told you I like to put detail on it. Those are my favorite kind of crackers. The ones that have a hint of salt. I had some today at lunch. No wheat thins with a hint of salt.
It's Wilson, I called it.
Thanks. That's a horrible bloody hand.
I thought you were trying to draw a clown face.
No. Castaway is a movie that has Tom Hanks in it. And he gets in a plane crash, and then he has a companion, Wilson. It's a volleyball. It's a Wilson volleyball. And that's his bloody handprint. Alright. Yeah, exactly. So, again, you don't have to put that detail into it if you don't want to. But the airplane pilot sees the raft. So here's your line of sight. Your line of sight will always be the diagonal line. From your diagonal line, you have two horizontals. You've got one coming across the top, and you've got one going across the bottom. I like to put them both in. I don't know which one I'm going to use to create a triangle, but I like to put them both in. It says the pilot sees this raft at a 26-degree angle of depression. Depression. Above a horizontal or below? Below. So then I need to put that 26 degrees right there, below the horizontal line. Next sentence. The airplane's altitude is 3 kilometers. What's altitude measured? Height, right? It's vertical, it's perpendicular distance from the ground. Perpendicular distance from the ground. 3 kilometers. We want to find the plane's surface distance from the raft. Surface distance, flat, is going to refer to the horizontal part. So we're trying to find this distance down here. So if you want to do plain Jane and just draw your triangle, then you would have what I have here highlighted. That would be your right triangle. I know that this side is 3. I'm trying to find the bottom side, but the only angle that I have inside of the triangle is 90. And I can't take a trig function of 90 degrees. We have to do it on the acute angles. So we're going to have to figure out what one or both of the other acute angles are.
26.
The one adjacent to it? Good, because our horizontal lines are parallel. Alternate interior angles will be congruent. Your angle of depression and your angle of elevation will always be congruent between the same two objects. So now in reference to the bottom 26, is 3 opposite, adjacent, or hypotenuse? Opposite. What about D? Adjacent. So which trig function should we use? Tangent. Good. The tangent of 26 equals the opposite 3 over the adjacent D. You agree with that equation? Okay. Cool. How would I put this in the calculator to find D? Yeah, 3 over tan 26. Kaden, did you already do 3 divided by tan 26? Can you do it? Can you round it to the nearest tenth for me too, please? Thanks.
6.2.
Good. So it's about 6.2 kilometers away on the surface. If I was measuring its actual distance here, would it be closer or further? Wouldn't it be more than 6.2? Since your hypotenuse, it should be bigger. Okay. Questions like this on worksheets, quizzes, and tests would be worth like 3 points. 1 point for your picture. 1 point for the correct trig equation and have it set up correctly. and then your third point comes from your answer. If it doesn't tell you where to round, you can pick. I usually round to the 10th if it doesn't tell me. Comprende? Sí, bueno. Uno más. Alright, number 7. A 6-foot man stands 12 feet from the base of a tree. The angle of elevation from his eyes to the top of the tree is 76 degrees. About how tall is the tree? Sorry, there's a grammatical error. There should be a question mark there. Again, you need a right triangle. I like to draw details, so. Bill's back. And Bill, remember, is 6 feet tall. And he's standing 12 feet from the base of a tree. Squirrels don't live in holes. Don't they make giant nests out of leaves?
That was a bird.
No. The really big bunches of leaves that are towards the tops of trees, those are squirrels. No, they're not.
There are holes in trees.
Well, those are for, like, not for squirrels.
So
they go in there all the
like
time.
those.
They're
Yeah,
for
they do.
owls. They're in
I bet a squirrel would be there. See, there you go. It's a decent sized hole for a squirrel. Or an owl. Chipmunk. Is that a pinata?
A pinata.
Oh. Oh, it's a donut.
Alright.
It's a donut.
So,
It's a squirrel trap. Bill's catching squirrels. Easily mistaken.
from Bill's eyes, he looks up at the top of the tree at a 76-degree angle of elevation. So, here's the line of sight between the top of the tree and Bill's eyes. From your line of sight, remember you have 2 horizontal lines.
Has some blueberry stuck in his eyes.
Angle of elevation. Above or below a horizontal? Above. So above that horizontal line right here, this is your 76 degrees. We're trying to find the height of the tree. We have to create a right triangle. So when I come down from this line of sight back to this horizontal line, there's my right triangle. We're trying to find x, the height of the tree. I need something else on my triangle. I don't have enough information yet. One side and one angle isn't going to do anything. What? Which leg? Good. The distance Bill is from the tree doesn't change much when I measure it from his eyes to the tree. So we can bring this 12 feet and relay it up there. Now, in reference to my 76 degrees, x, opposite, adjacent, or hypotenuse? Opposite. How about 12? Adjacent. So which trig function should we use to find x? Tangent. Good. The tangent of 76 equals x over 12. Hey, just write this down. I'm sorry. Grant, how would you punch that into the calculator?
12 times the tan of 76,
And you got approximately
48 feet.
good. 48 feet is this vertical distance on the tree. Not the tree, on the triangle, excuse me. Is this vertical distance on the triangle represent the entire height of the tree? No, because the angle is starting above ground level. We have to take into account this 6 feet. So if I want to find the entire tree, then we're going to have to add 6 to whatever we had gotten for x. That'd be 54, right guys?
Yes.
Alright, so our tree is about 54 feet in height then. The angle does not start at ground level, then you're going to have to add that in. Part 2, B. If the man, Bill, releases a pigeon that flies directly to the top of the tree, how far will it fly? So Bill's gonna take this pigeon and release it, and it's gonna follow his line of sight. When they say directly to it, so we have a magic world here. Our pigeon is flying along this line of sight here. That's what I'm trying to find. So we're just finding a different side of the triangle. In reference to 76, y is what? Hypotenuse, good. So I have the adjacent leg 12, and I'm trying to find the hypotenuse. Which trig function can I use? Cosine, right? Cosine is adjacent over hypotenuse. So cosine of 76 would be 12 over y. Riley, how would I push this in the calculator to get y?
12 divided by cosine of 76.
Good. Did you already do it?
Yeah,
What did you come up with?
49.5.
Good. So then our distance, pigeon flies, about 49.5 feet. Last part. What is the angle of depression from the treetop to the man's eyes? Depression has to be above or below a horizontal. Below. So we are looking for this angle measure here for part C. Everybody? 76. Because the angle of depression and the angle of elevation are what kind of angles? Alternate and series. Questions? Okay. Here's your assignment. Tomorrow we have
Yeah.
assignment over the
Oh,
same.
1 through 23.
It's like 12 questions, you guys. It's not very many. Part of them you have to tell me what type of right angle it is from what to what. Some of them the pictures will be there for you. Some of them you have to draw them on your own.
Why do we get points off not drawing a picture? I'm boring. Drawing
Fractions are.
Kevin, you don't have to draw them, but just understand that you'll lose 1 point then.
No,